Hi guys, today we are going to talk about 6.5% of increase and decrease notes. Our I can statement, I can find percents of increase and decrease. Percent of change. A percent of change is the percent that a quantity changes from the original amount. So typically, when we're looking at the percent of change, we want to find the change in something, and change, we are going to use some subtraction. We want to find the difference in the amount that we are starting from and the new amount. And then we are always going to divide by the original amount. So more specifically, when we're looking at a percent of increase, so when the original amount increases, the percent of change is called a percent of increase. So we're going to take the new amount minus the original and then divide by the original. When we are looking for an amount that decreases, the percent of change is going to be the percent of decrease. Percent of decrease is the original amount minus the new amount, and always divide by that original that we started with. In example one, we are finding a percent of increase. So the table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? So on Saturday comes before Sunday if we're looking at our weekend. So from Saturday to Sunday, okay, Saturday started to Sunday. Saturday I had 2 hours. Sunday I had 4.5. So let's look up here. I know to go from 2 to 4.5, I'm increasing. So I'm looking at a percent increase, which means I have to take my new amount minus the original amount. So I am going to do 4.5 minus 2, and I am going to divide by that original amount. So the original amount, the first day that I started with was Saturday, so I'm going to use that amount. So I'm going to divide by 2. So I have 4.5 minus 2 divided by 2. So 4.5 minus 2 is 2.5, and I'm dividing by 2. Now, because the numerator is larger than the denominator in this case, I already know my percent is going to be greater than 100. So when I divide those out, I get 1.25. But it's asking, what is the percent? 1.25 is not a percent. I cannot just put my percent sign on there. I need to just kind of remember back to sections 6.1 and 6.2 when we're changing our percents from decimals, or changing to a percent from a decimal. We're going to be multiplying by 100. So when I multiply by 100, I'm going to actually be shifting that decimal point over twice. So that means I have 125% change. And in this case, it's an increase. All right, go ahead and pause the video, and you are going to try the next two on your own. Okay, let's look at example 2, finding a percent of decrease. The bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? So 2012 comes before 2013. So this would be my original amount, and this would be my new. So I'm going to put an O and an N for 2013. So what is the percent of change from 2012 to 2013? So 2012, I had 28 runs or home runs, and then in 2013, I had 20. So I really am starting with the larger of the two, because I'm going to do the original minus the new. So I'm going to do 28 minus 20, and I want to divide by the original amount that I started with. So the original amount was the 28, so I'm going to divide by the 28. So that leaves me with 8 over 28. Okay, remember guys, it's going to be original minus the new, and always dividing by that original. So 8 divided by 28 is going to give me 0.286. And then we are going to shift our decimal point or multiply by 100. So it gives me 28.6 percent decrease on number of home runs from 2012 to 2013. Okay, we're going to look at what we call a percent error. So when we are estimating things, okay, we may overestimate or underestimate, and on a lot of those things, there's some leeway for error. So it gives us a little bit of error on time, if we overestimate or underestimate, we want to have a little bit of cushion room. So we're going to look at that percent of error. The percent error is the percent that an estimated quantity differs from the actual amount. So we want, if there ever is a percent error, we want to have a lower amount of percent error. So let's say you are estimating the length of your classroom and you're estimating it to be 16 feet. When you are given the chance, you measure it and it is actually 21 feet. So we want to find the amount or the percent of error. So we need to figure out what was the amount of error. So if I said, oh, it's 16 feet, but I measured it and it's actually 21, what is the difference? What is the error between those two numbers that I estimated? And then just like the original, okay, this time though, we're not going to do the estimate. You're going to do the actual. So the estimate is not the one we're doing. We're going to do the actual. What should it have actually been? So that's going to give me 5 divided by 21. So 5 divided by 21 equals 0.238, which is 23.8%. So it was a 23.8% error. All right, go ahead and pause the video and try the next couple try on your own. All right, guys, we are back. We are going to try to find a new amount. So if you are increasing, you are going to add the percent as a percent, but without the decimal, okay, to 100. And so if you are increasing something by 18%, you are going to take that 18 without your percent sign, without the decimal, okay, and add it to 100. We don't have a percent sign there. We're not having that decimal. We're not doing 0.18 plus 100. It's 18% plus 100% gives us 118%. Now, we can turn it back into our decimal form, which is 1.18. 118% or 1.18 are equivalent. Okay. Now, if we're increasing something by that 18%, you are going to multiply the number being increased by the new percentage. So what that means, if I am taking 20, say I had 20 students get an A last year on a test, and I want to increase that by 118%. I am going to multiply that by 118% or 1.18. Okay, so I would be multiplying that by my new number, my new percentage. And that's going to tell me what my goal is going to be to get students to get A's on my test. Okay, let's look at the second part. If it is decreasing, so if I'm decreasing my amount, so I'm going to subtract the percent as that percent, but without the decimal, from 100. So what that means, if I'm decreasing something by 23%, I'm going to take my 100%, which is a whole amount, minus the 23, which gives me, there should be an equal sign, 77% or 0.77. And this is the version that I used up here. Okay, so that's the one I might want to use here. So then it says to multiply the number being decreased by the new percentage. So again, you can multiply it by the 77% or the 0.77. Don't forget, if you're multiplying it by 77%, you actually have to use that percent. Okay, you can't just multiply it by 77. That's a whole. A percent is not a whole. It is a portion of 100. So in this example, if I want to decrease the number of students that failed my test, and let's say I had 10 students last year fail my test, and I want to decrease it by 23%. So I'm going to multiply it by the amount of percent that I want the students to pass it. So I'm going to multiply it by 0.77. Okay, so I'm decreasing it by 23%. So when I multiply those together, it will give me my new total of students that I need to get to pass my test. All right, let's take a look at some other examples. So number 5, if I am able to swim 12 meters and I want to increase that by 15%, so I can take my 12 meters, I have my 15%, actually let's go back. I have my 15%, let's start there. I'm going to add it to my 100%. So that gives me 115%, which means if I turn it into my decimal form, it's 1.15. Remember, you move your decimal point over twice. So it's 1.15. So I would take my 12 meters that I was already able to swim and multiply it by 1.15 because I'm increasing the amount. So that means it should be greater than 100% that I'm multiplying it by. So I do 12 times 115. That's going to give me 13.8. So that means I have, if I increase my ability to swim, let's say every week, my goal is 15% to increase it by, that means by week 2, I'm going to be able to swim 13.8 meters. Okay, let's look at number 6. We have 22 liters increased by 60%. So I have 22 increased by 60. So I'm going to start with my 60%. I'm going to add the 100%. That gives me 160% that I'm trying to increase it by. So that means it's 1.6. So I'm going to take my 22 liters and multiply it by 1.6. When I multiply it by 1.6, that's going to give me 35.2. So now I have 35.2 liters if I increased my 22 liters by 60%. Okay, let's look at 55 points decreased by 40%. So I'm going to take my 100% minus my 40%. That leaves me with 60%. So if I'm decreasing something by 40%, I still have 60% left. That's what it's saying. So I'm going to take my 55 points and multiply it by 0.6. When I take 55 times 0.6, which is my 60%, I am going to get 33. Okay. Then let's look at 50 penalties decreased by 32%. So again, I'm starting with my 100%, subtracting the 32%, and that leaves me with 68%. Okay, and that 68%, I should have changed this over here, the 60.6. This is going to be 0.68. So I'm going to take my 50 penalties, and I'm going to multiply it by the amount of penalties that would still possibly be left. And that means I'm going to have 34 penalties left after it's been decreased by 32%. All right. So let's go ahead and pause the video and try the next 4 on your own. I guess there were actually 6 that you were supposed to try on your own. So if you have not finished those last 2, go ahead and pause the video, try those on your own, and then go ahead and start shifting into some of these others. We have the error analysis, which you should be able to do by yourself. Remember, over here on the right, there is an error in this problem that the student has tried to do. I always suggest that you try it on your own first. You can do it over here. Try it on your own first before looking at theirs to see what the problem was. Okay, number 20, you are doing a practice problem on the percent error. So how much you estimated or guessed that the pig weighs 20 pounds. It actually weighed 16 pounds. So it's a very, very simple, it's very similar to the last one, okay? But a very simple error that you're trying to find. So what percentage error did you have? Go ahead and try 21. A cereal company fills a box with 16 ounces of cereal. The acceptable percent error in filling a box is 2.5%. Find the least and the greatest acceptable weights. One thing I just want to point out is if you are increasing 16 ounces by 2.5%, So if you're taking the 100% and increasing it by 2.5%, you're going to end up multiplying 16 times 102.5%, or that's, I have to shift it over, 1.025. So times 1.025, and that will give you your increased amount. Over here, you are doing a decrease. So you're going to start with the 100 and you're going to subtract the 2.5% to get some amount. Then you're going to take your 16 ounces and multiply it by that unknown amount to get your decreased amount. Okay. 22, I will give you a heads up, that is pretty challenging. One thing you need to make sure that you're looking at over here, these seconds are out of 60. Okay, because seconds are out of 60, not 100. That's what makes it really challenging, is a lot of students put 100 as a denominator when you're looking at like 45 seconds or 51 seconds. It's out of 60, not 100. Okay, go ahead and then try the next couple on your own. I think there's only 2 more. Okay, good luck.